Did you know that sound waves can create powerful physical effects? Prepare to be amazed. Welcome to another episode of Scientific Facts, where we break down complex concepts into easily digestible bits of knowledge. Today, we're unveiling the incredible power of sound waves. We often think of sound as merely something we hear through our ears. But did you know that sound waves can cause astonishing physical effects? From breaking glass with an opera singer's voice to levitating small particles, sound has powers beyond our imagination. It's not just about noise, it's about physics, art, and even health. Historically, sounds have been used in a variety of ways, from ancient rituals to modern scientific research. This isn't about your everyday clatter. These sounds are precisely calculated frequencies and amplitudes that yield unique phenomena. You might have heard about resonance and vibrations, but how do they translate to actions? Grab your headphones, sit back, and get ready to delve deep into the auditory realm of science. Let's meet Jane, a passionate acoustics researcher who spends her days in the lab surrounded by equipment that looks like it belongs in a sci-fi movie. Jane's life goal is to harness the power of sound waves to address global challenges. Imagine influencing plant growth or cleaning polluted water using sound. Jane, with her characteristic zeal and curiosity, starts her experiment with a simple setup: a speaker, a frequency generator, and a few tiny particles. Her challenge? Can she make these particles levitate using only sound waves? For those curious, this process is known as acoustic levitation. And it's not just a lab trick. Researchers around the world are exploring its potential for things we can only dream of today. Jane emits a low-frequency sound wave, waiting in anticipation. The particles begin to vibrate. Some even rise slowly, defying gravity. How is this possible? The sound waves create a standing wave, and the particles find themselves caught in areas of compression and rarefaction, called nodes. At these points, the outward forces equal the gravitational pull, holding the particles in place. As she tweaks the frequency, the particles dance in the air, moving elegantly from one node to another. Jane's assistant, Tom, captures this moment with his camera, exclaiming, "Who would have thought sound could do this?" Tom's excitement is contagious. Next, Jane decides to push the boundaries. Can sound waves break glass? She places a delicate wine glass near the speaker and slowly increases the frequency. Every material has its own resonant frequency, the particular vibration at which it naturally oscillates. When sound waves match this frequency, even sturdy materials can shatter. The glass trembles, vibrating as if alive, and then, with a crescendoed note, it fractures dramatically. These demonstrations are not just spectacular, they hint at sound's vast potential. Beyond party tricks, acoustics play roles in medical therapies such as lithotripsy, which uses focused ultrasound to break kidney stones, a non-invasive alternative to surgery. Acoustic research is even venturing into the architectural world. The design of concert halls and auditoriums relies heavily on achieving perfect sound quality. The manipulation of sound waves helps us understand and control our acoustic environment better. Imagine working in an office where sound waves reduce noise pollution, enhancing focus and productivity. Jane's experiments show us that sound is a formidable force waiting to be harnessed. The ripple effects of her research promise innovations in medicine, technology, and the environment. We often take sound for granted, considering it just a side effect of vibrations. But as Jane demonstrates, sound is an untapped resource. So next time you listen to music or hear a bird chirping, remember the hidden potential that each sound wave carries. Sound isn't just a wave of vibration. It's a gateway to new possibilities waiting to be uncovered. Don't turn down the volume on sound's potential. It's more phenomenal than meets the ear.